Okay, so the question on top reads, in the diagram, P is the center of the circle, V, which coordinates is K and 1, and W are the endpoints of the diameter to the circle. The circle intersects the y-axis at B and C, so there are two y-intercepts. BCVW is a cyclic quadrilateral. CV is produced to intersect the x-axis at T, and then OTC, the angle OTC, is alpha. Okay, that is the angle, that's the angle of inclination for the line TC. Okay, it's the angle of inclination for that line. Right, let's have a look at the first question. Um, 4.1 says, the radius of the circle is square root 10 units. Calculate the value of K if the point V is to the right of point P. Clearly show all calculations. Okay, what are they saying here? The radius is square root 10 units. We need to calculate K, which is the x coordinate for point V, if point V is to the right of point P. Okay. Using the information given, what ideas do you have, or what suggestions do you have to come up with a way to solve the value of K?
So I would
Mohammed?
use the distance formula.
The distance formula, correct. The distance formula. Okay, because they're giving us the radius, the distance of the radius. We can just use the distance formula. Does anyone have a different suggestion? Would you all agree with this? Okay. So let's do the distance formula then. Remember the radius is square root 10. Okay. So we're going to say square root x2 minus x1 squared plus y2 minus y1 squared. Okay. And now we substitute the distance for the radius as square root 10. And then we substitute all our x values and the y values into the formula. So P's x value is -3. And then we minus the x value at point V, which was k and 1, right? So the x value there is k, so we minus k squared plus the y value at point P, I think that was 4, so it's 4 minus 1 squared. Okay. Okay, Daniel, how can I go further to solve K? Because I basically have a surd equation. What can I do to get rid of the surd?
So you can square both sides to cancel out the square root.
Correct. Okay. So we square both sides to cancel out the square root. So we are left with 10 on the left-hand side. And then we just left with those brackets on the right-hand side. So let's multiply out. The shortcut for multiplying out this is going to be -3 squared, which is +9. And then -k squared, which is +k squared. And then you double the product of the middle the middle two terms. So the product is -3 times -k, which gives us positive 3k. And so we double that. So we have positive 6k. So even though this bracket has a bunch of negatives, when you multiply all that out, you basically just get a bunch of positives. Okay. And then we're going to multiply out the 4 minus 1. That's 4 minus 1, which is 3, squared. That is 9. Okay. So plus 9. I'm going to take everything over to the right-hand side. K squared plus 6k. 9 plus 9 is 18. If we minus the 10, then it's just 8. So it's plus 8. Okay. The factors of 8 that's going to give us this middle term, 6, is 2 and 4. Okay, so the factors of 8 is 2 and 4. So we have k plus 4 and k plus 2. And therefore, k is either equal to -4 or k is equal to -2. Now let's keep in mind, they did tell us that k is to the right of p. So p's x-coordinate is -3. And if k is to the right, then k would be -2. Okay, because to the left it will be -4. To the right it's the -2. Okay, so this is how we can solve that value of k using the distance formula. Okay, so now also another thing is, once you get an answer, please remember to fill it in on your sketch, right? So I know you guys don't have the printed out versions of this, but if you had now a printed out copy or maybe a drawing on your page, you will then fill in the coordinates there that we worked out. So these coordinates is -2 and 1. And also another piece of information is the length of the radius, which was square root 10. Okay, that's another important piece just to put in on your sketch. Okay. So the next question reads, the equation of the circle is given as x squared plus 6x plus y squared minus 8y plus 15 is equal to 0. Calculate the length of BC. They're giving us the equation of the circle and they're asking us to calculate the length of BC. So if we just go here, BC is, or B and C are both the y-intercepts of the circle. Okay, they are the y-intercepts of the circle. So how can we work out a y-intercept? Jesse, how would we work out the y-intercept of this circle?
So wouldn't you let x be 0?
That's correct. Okay, so the equation that they gave us here, we're trying to work out the y-intercept, so we're going to make x 0. Okay. If you make x 0, this x squared becomes 0. X also becomes 1. Just factorize that trinomial, and that's going to give you the y-intercepts. Okay, so do that now. Okay. X squared minus plus 6x. Okay. Okay, once you guys have answers, please let me know what they are. You can just type it in the chat. Okay, so I basically get two, yes, thank you. So I get the two intercepts as 5 and 3. That would mean that the distance between B and C is 2 units, because the one's at 3, the other one's at 5. So the distance between them is 2 units. Okay, so you have to conclude by saying, therefore, BC is equal to 2 units. Okay, that's the final line that you write there. Okay. Don't forget to answer the original question. Oftentimes I forget to do this, where I do the whole calculation and I forget what the question was. So always go back to check, wait, what were they asking me? So they asked you for the length of BC, write it down after your calculation. Okay, so we can move on to the next question now. Here they are giving us the answer for K. We had to calculate it in 4.1, but now they're giving us the answer. They're saying, if K is equal to -2, calculate the size of alpha and calculate the size of angle VWB. VWB, okay. Let's first work out the angle of alpha. Now, I think I did this in a previous lesson where we went through the angle of inclination. Okay. This angle alpha here is the angle of inclination for the line TC. Okay. Lauren, what is the formula to work out the angle of inclination of a line?
Tan theta is equal to m, sir.
Correct. In this case, we're going to say tan alpha because the angle is alpha. So we say tan alpha is equal to the gradient of the line TC. Okay. What is the gradient of the line TC? We have V's coordinates and we have C's coordinates. So we can work out the gradient of this line. V and C lies on the line TC. Okay, both those points is on that line. So C's coordinates is 0 and 3, and V's coordinates is -2 and 1. So let's do the gradient. 3 minus 1, 0 minus -2. So 3 minus 1 is 2. 0 minus -2 is also 2. That means that the gradient is 1. The gradient is 1. So tan of alpha is equal to 1, which means that alpha is equal to arctan of 1, which is 45 degrees. Okay. And that's how you work out that angle. Okay. Now, the next question says, calculate the angle VWB. So let me just erase all of this. The angle VWB. VWB is that angle over there. We have the coordinates of B, we have the coordinates of V, we also have the coordinates of C, we have the coordinates of P. We have a lot of things, basically. How can we use these things to work out that angle? Yeah. Anyone with a suggestion, please let me know.
So
Yes.
would I be right if I see it like, okay, there's like 2C, like where C is, it can be C1 and C2, the other side of the angle.
Wait, let me just mark that in. So C1, let's make the one inside the cyclic quad. Let's make that C1 and the C2, okay?
Not that side, sir, the outside one.
Ooh,
Where
okay.
they vertically opposite one another.
C1 and like that.
Yes.
Okay, okay, fine.
Are they vertically opposite one another?
They are, yeah.
Now, can I say like C2 is equal to W?
Yes, what's your reason?
Exterior angle of cyclic quad.
That's correct. C1 is also equal to W, exterior angle of a cyclic quad.
Oh yeah.
Both of them are,
Yeah.
yeah, both of them are exterior angles of the cyclic quad. How are you going to calculate C1 though?
I already know like O would be 90 degrees.
Mm-hmm.
And then I would say C1, you can calculate angles in a triangle, which is 45. And then I'm done.
Oh yeah. Okay, okay, cool. So here's a nice way to go about it. Angle alpha is 45 degrees, right? There's a triangle there. TCO is a triangle. So if O is 90 degrees, alpha is 45 degrees. That means that the angle there by C is also 45 degrees. Okay, so let me just mark it in there. Angle C is 45 degrees. Now this angle is the exterior angle of the cyclic quad. So it should be equal to the opposite interior angle. So therefore, angle W is also 45 degrees. Okay, very nice. So here we had to use some circle geometry or just normal geometry, basically. We had to use here. Muhammad was even mentioning this angle here being also 45 degrees because it's vertically opposite. This one inside the cyclic quad will be 135 degrees because that's angles on a straight line. So you can see this angle here and the one that we had to calculate, those two are equal to 180 because opposite angles of a cyclic quad adds up to 180. Okay. So what do we start? How do we write this out? Let's start by saying angle TCO. Okay, I'm not going to say C1, okay, because they didn't give me a 1 there. I can't just say C1. So I'm going to say angle TCO is equal to 45 degrees, sum of angles in a triangle. Right? And then I say, therefore, angle VWB, this is the one that they wanted us to calculate, This one is then also 45 degrees because of the exterior angle of a cyclic quad. Okay, so just those two reasons that you have to give. Sum of angles in a triangle, exterior angle of a cyclic quad. Okay. Question 4.4. A new circle is obtained when the given circle is reflected about the line y equal to 1. The first question, determine the coordinates of Q. The coordinates of Q for the new circle. Second question, determine the equation of the new circle. Then question 3, equations. Okay, we'll come to that question later on. Let's first find the center of the new circle, and then let's determine the equation of that circle. They say it's reflected in the line where y is equal to 1. That's where it's reflected, okay. In the line y equal to 1. Okay, so what should this line look like? Y equal to 1. What should this line look like? Huda, what would this line look like? Y equal to 1.
So I think it's a horizontal line passing through y1.
That's correct. Okay, so a horizontal line passing through where y is equal to 1. Okay. And if this circle, if this new circle is reflected in that line, that should mean that there's a circle drawn below this, almost like a reflection. Okay, that doesn't look very nice, but let me just get some more space, then I can do it nicer. Okay. Okay, so if this is the line where y is equal to 1, then the reflected circle should be something like, oh, that's more of oval, but you get the point. Okay, it's reflected like that. What is the coordinates then for this? Let's say the center of this circle is Q. What will the coordinates for point Q then now be?
So would it be -3, -3 and -4?
That's correct. No, no, not -4.
Isn't it -3?
-3 and -2, I think.
That is correct. -3 and -2. Let me explain why. So you all got the fact that the x value didn't change, right? The x value didn't change because it's being reflected, like the graph is, or the circle is basically just drawn below. Okay, now the reason why the y value is -2 is, think of where this line of reflection is, and think of how many units the circle or the center of the circle is above that line. So it's like 3 units above the line, where y is equal to 1 to where y is equal to 4. That's 3 units higher. So if it's being reflected, the distance should be the same, but in the opposite direction. So instead of going 3 units up, you now go 3 units down from 1. And 3 units down from 1 is at -2. Okay. So it's being reflected in the line y is equal to 1. And so the x value stays the same, but the y value changes to -2. Okay. Now, we need to find the equation for this circle. So what's the equation for this new circle? So Waida, could you give me the answer to this, please? The equation
I
for the new circle.
think it's x plus 3 squared plus y plus 2 squared equals 10.
That is correct.
Not
Okay.
sure.
Because the center of the circle was at Q, -3 and -2. The radius of this circle will be the same as the radius for the other circle, because the only transformation they gave was that was reflected. They never said if the circle is bigger or smaller. They said it's just reflected. So the radius should be the same. Therefore, the equation is x plus 3 squared, y plus 2 squared, and then the radius is 10 or square root 10. We have to square that to get 10. Okay, perfect. Just take this off as well. Okay, this question I assume is going to be a bit difficult or more harder than what we've done before. Oh, but it's only 2 marks. Okay, maybe not so. Maybe it won't be so bad. Equations of the lines drawn. Oh, wait. Determine the equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the 2 circles. Determine the equations of the lines parallel to the y-axis, passing through the points of intersection of the 2 circles. Okay, got it. 2 marks for this answer. So really what you need to do is understand what they are saying. So I'm first going to highlight the top circle. Do I do it in black? Okay, so let's highlight this one in black. And then we'll draw the new one in blue. And then they're saying that there's 2 lines, which is, it's basically vertical lines because they are parallel to the y-axis and they are passing through the points where the 2 circles intersect. Okay, so where does the 2 circles intersect? It's at this point here and at that point there. So it's at point V and at a point that is not given a name. But I think we already worked out those values or those coordinates. What will the equation for these 2 lines be? These 2 vertical lines. Anyone? Okay. Earlier on, we did the equation of a horizontal line. That was y equal to. Now we are doing the equation for vertical line. So that should be x is equal to. So basically, we just need to know what are the x values at those points. We already identified that the x value at point V is -2. So for the first line, we can say x is equal to -2. But what about the second line? What was the x coordinate there? Remember, this is where y was equal to 1. This was where the y value was equal to 1. What was the x coordinate there?
So would it be -4?
That's correct, -4. Okay. We answered this basically in the first question. I just think sometimes they phrase the question really weird, but it's to like cancel any ambiguity. Like they don't want to there to be any like loopholes or any, you know, missing information or misleading information. So to cancel out all of that, they structure the question in such a sophisticated way that it's difficult for us to read and understand what's going on. So what they were basically talking about here was this new circle where it intersects with the original circle. If we draw lines there that is parallel to the y-axis, what are the equations for those lines? And so there, that's how you find those equations. But let me just see, how did they phrase it? Because when I read it the first time, I also didn't know we were supposed to do this. Okay, so they say, determine the equations of the lines drawn parallel to the y-axis, passing through the points of intersection of the two circles. Yeah. Okay. Anyways, that's it for analytical geometry. I'm going to move on now to maybe a trigonometry question. Okay, I think we can do revision of Euclidean geometry in our face-to-face lessons, but yeah, let's move on to trigonometry. So to continue with trigonometry, let's have a look at this question, which is worth 80 marks. Okay, so you now have to think back to all the trig theorems and, well, not trig theorems, but trig formulas and identities and such. So there's the reduction table with 180 and 360. There's the cofunctions table with 90 and 270, but mainly we just make use of 90. There's the identities, like tan equal to sine over cos, and the reciprocal identity of 1 over tan equal to cos over sine. Okay. There's also the identity that sine squared plus cos squared is equal to 1. And then you can also manipulate this identity to give you 2 more identities that might look something like this. But this is all grade 11 revision. Okay. Then we have grade 12 identities, such as compound angles. Like when you have sine of an angle plus another angle, this is equal to sine of angle A times cos of angle B plus cos of angle A times sine of angle B. Okay. And if it was cos, let's say it was cos of angle A plus B, then this becomes cos of angle A times cos of angle B minus sine of angle A times sine of angle B. So notice when it's cos, the plus inside the bracket changes to a minus. But if it's sine, then the sign will stay the same. Okay. So I think I heard someone say sine same, cos change. So that's a nice rhyme you can use to remember this. Sine same and cos change. Okay. Then there's also double angle identities. For sine 2x, this is equal to 2 sine x cos x. Okay. And for cos 2x, there are like 3 identities for this. Let me just admit someone to the group here. Who is this? Okay. Someone lost connection. Okay. And if it was cos 2x, you would then say, well, there's 3 identities. So it either could be the 2 cos squared minus 1, or it can be the 1 minus 2 sine squared, or it can be the cos squared minus sine squared. So there's many identities for this. Yeah, and all of this is so important for the work we're about to do now. Okay, so let me just clean everything up, and then we'll start with the questions. So this was your refresher course. Now we're going to get into the work. Okay. .1. Simplify the single trigonometric term. Okay, so the first thing I want you to do is write down this expression. So tan negative x times cos of x times sine x minus 180 degrees. Okay, now that you got it, let's work through it. Tan of negative x. Let's first reduce that first expression. Tan of negative x. Sydney, what is this equal to?
Negative tan x.
That's correct. Tan of a negative angle becomes negative. So negative tan x. Okay, cos will stay the same. Sine x minus 180. Ruman, what is sine of x minus 180? Just keep in mind that is not the same as 180 minus x. So what should I do?
So it's negative sine x.
Correct. That is equal to negative sine x. Can I just ask, how did you come to that conclusion?
I memorized it.
Okay, you memorized it. Okay, that's also one way of doing it. But just to explain, there is a lot of ways of doing this actually. So okay, you mentioned memorized it. Did your teacher perhaps draw another Cartesian plane that have these, I guess, inverse, what do you call that when it's like, when it's the opposite? So instead of having it 180 minus x, it's x minus 180. Did she or he give you quadrants for when it's like that? Or how do you mean you memorized it? Or you just do it once before and you, because it was right, you were like, okay, I'm gonna memorize this?
So we have it, they have it written down for us. So we had like 90 minus theta and we had all of the values. So easier to memorize.
And for this as well, for when it's in the incorrect form.
Yes, sir.
Okay. Okay, because I normally just stick to the original one, but then I will say, if it is given in such a weird form, what you can then do is add 360 degrees to that to get it into a better form. Sometimes you have to add 360, other times you have to minus 360. But let's say for this question, where we had sine x minus 180, no? You can like add 360 to that, which will then make it positive 180. Now, because it's positive, you can swap it out. So then you can say 180 plus x. And that is now the third quadrant where sine is negative. So sine is negative in this quadrant. Yeah, so negative sine x. Okay. Okay, when you multiply this negative with that negative, the negatives will cancel. And another thing I can do here is change tan into sine over cos. So I'm going to change this tan into sine over cos. Remember I said the negative is cancelled. So I just have these terms here with the minus 1 over there. This cos will cancel out with that cos. And this sign multiplied by that sign is equal to sine squared x. And we still have the minus 1. Okay, now sine squared x minus 1 is not necessarily an identity. So we need to swap that around. So I'm going to swap this around. That's going to be equal to negative 1 minus sine squared. And that is an identity. This is equal to cos squared x. Okay. Any questions here with the first one? Any questions that some of you might have? Okay. So there at the very end, I just swapped around the cos and the 1, or it was the sine and the 1 to give us that answer. Okay. Okay, then question 5.2. I really love these questions. Again, just copy down the question. Given that cos of 35 degrees is equal to m, without a calculator, determine the value for each of the following. Okay. So, with this type of question, you always start with a triangle because they're saying we can't use a calculator. If you can't use a calculator in trigonometry, you're going to have to use a triangle. So, we draw a triangle of 35 degrees. Opposite we don't know because this is cos. So cos is adjacent over hypotenuse. So the adjacent will be m, and the hypotenuse will be the invisible 1. And then the opposite will be, we'll calculate that using Pythagoras, which is square root 1 minus f squared. Okay. Right. Now, without a calculator, let's work out the first question. Cos of 215 degrees. Muhammad, what will we do here?
I turned it in like 180 minus 35.
180 plus 35.
Sorry,
Yes.
180 plus 35.
Okay, so that's in the third quadrant. Is cos positive or negative?
Negative, so.
Negative cos 35. And because we know cos 35 is m, we can just say that this answer is equal to negative m. Okay. Here you go. I think this is a 2-mark question. 1 mark for the reduction and another mark for expressing it in terms of m. Okay, that's the whole goal here, to express everything in terms of m. Okay, Jalen, going back to you now. Sine of 20 degrees. How could I work out what is sine of 20 degrees? Now that I'm asking you this, I'm realizing this is actually not as easy as I originally thought. But do you have any ideas here?
I had one.
Wait, what did you say? Sorry, Mohammed, was that you? Did you want to say something?
Sorry, sir, my mic was on. I didn't mean to.
Okay.
But I don't know. I wrote my 55 angle in there. In
Okay,
case
let
it
me
helps.
put that as well. Yeah.
So I think I have
That's
an
it.
idea.
Okay. What's your idea?
90 minus 5.
Yeah. Oh wait, no. I would say sine of 90 minus 70 and then use 70 as a double angle.
Oh, that's so clever. Okay. So you are changing sine 20 degrees into a co-function. So that becomes cos of 70 degrees. And then you are saying, since 70 degrees is twice as big as 35, we then can use a double angle. That's correct, a double angle for cos. And I think the double angle we should use for cos, like the one that will work best here will be the one that looks like this. So it's 2 cos squared x minus 1. The reason why I want to use this one is because we already know what cos of x is, or cos of 35. Cos of 35 is m. So it's going to be easy if we just use that one. Okay, so let's do this. So we didn't even need to draw a triangle here, because for both questions, we're not even going to use that opposite. So sine 20 degrees, we are changing that into cos of 70 degrees. So we said cos of 70 is basically 2 times 35. So we're going to use the double angle, 2 cos squared 35 degrees minus 1. And since cos of 35 is m, we can just say 2m squared minus 1. How'd you like that? Nice and easy. Cool. I don't know what I was thinking. I was also thinking of some double angle, but it wasn't as easy as that. In fact, I was first thinking of compound angles. I was trying like 45 degrees minus 35 degrees, but then that gave me 10 degrees. So somehow I had to go from 10 to 20, but I don't know if that would have worked.
I think
yeah.
I used the compound angle and I got to 55.
55. 55 is
Because
the angle in
55
the...
is the other angle in the triangle.
Oh, okay. So how did you do it?
I said like sine 90 minus 35.
And then you got 55. Wait. Sine 90 minus 55. But this will give you the answer for sine of 35. Isn't it? We're looking for sine of 20. Am I understanding you wrong here?
I'm probably doing it wrong. I just remember, I don't know, because I erased it, I did it, then I erased it, and I don't remember what I did now.
Okay. Okay. But I am going to try out my method, but not now. I like that one better because we got so much more quicker to the answer. I assume,
Sir,
yes.
sir, isn't it that sine 90 minus theta is equal to cos theta?
Yes. Yes.
So then you would with cos 35.
Correct. That is sine 90 minus sine 90 minus 70. So you calling 70 the theta, and then this is then equal to cos theta or cos 70. Yeah. That's why I just straight away said that sine 70 or sine 20, sorry, is equal to cos 70. So if there are different functions, if it's cos and sine, then the angles must add up to 90 degrees. That's how you know they are co-functions. Okay, but this only applies to sine and cos, not tan. Okay. Moving on, general solution. Okay, again, write the question down first. I'm going to do the same, and then we work through it together. Okay. Let's see who's going to help me with this question. Lauren, see this initial expression, the cos, and the sine, with a plus in the middle. How can I reduce this expression? When we looked at the identities in the beginning, which identity does this one resemble the most?
Cos A.
Cos A, that's what I heard. Cos A plus B. That's what you wanted to say. Anyways, it is correct. Cos A plus, no, actually, no, I'm lying. Cos A minus B. Cos A minus B. Remember, for cos, the sign will change. So the plus becomes the minus in the shortened version. So here, I'm going to say cos of 4x minus x. Okay. Which is then just equal to cos of 3x. Okay. And we need to solve x in this case. So remember, I always gave you the 2 steps. First, find the reference angle, and then find the quadrants. So let's first find the reference angle. We'll do that by taking shift cos of the 0.7. What's that equal to? Shift cos of the 0.7.
I'm getting 45.5730.
45 say again?
0.5730.
Okay, so if we round it off to 1 decimal place, what's it going to be? 45.6.
6.
0.6. Okay, thank you. 45.6 degrees. Now we ask ourselves, in which quadrants is cos negative? Okay, and it's negative in the second quadrant and then also in the third quadrant. Okay, so for the second quadrant, we say 3x, which is this angle. So 3x is equal to 180 minus 45.6. Okay, then we just go ahead and we solve x. For the next one, we'll have to say 3x is equal to 180 plus 45.6. And if you are wondering where does this 180 plus and 180 minus come from, comes from the second and the third quadrant of the reduction table. So remember, in the reduction table, the second quadrant is the 180 minus, and the third quadrant is the 180 plus. Okay, this is how we solve general solution questions. Okay, so you will just go further by adding those angles, then dividing it by 3. Okay. Uda, do you mind giving me the final answers for these, please?
So I got 44.8 plus k times 180. I mean 120.
Sorry, 44.8
0.8, yes.
plus k 120, and the last one?
75.2.
What is Wait. Which? Wait, what? That can't be right. Did you say 25.2?
No, 75, so
75, sorry.
it's fine, sir.
75.2. Okay. Thank you. And why are we saying plus K 120? That's because we divided by 3. Okay, so usually for the cos graph, we will say plus K 360. But in this case, we say plus K 120 because we divided it by 3. Okay, brilliant. I think we're going to do the last question now. Oh, guys, let me also just let you know that we might start with longer lessons, like having double lessons on a Wednesday. I might even incorporate that to the Saturday lessons because you are writing exams soon. I saw the dates of settlers that you guys are writing. I also saw the dates for PHA. I don't know if Fairbairn, I don't know if people from Fairbairn gave me their dates. Tamlin, if you can give me the dates that you guys write at Tigerberg, that will also be great. Yeah, because I want to prepare you towards that. Okay, and you're going to be writing on calculus also, so you must please attend Sunday's lesson. And anyone else, if you start with calculus, then just attend the Sunday lesson. Okay. Prove the identity. Again, start off by copying down this, and then we're going to simplify it. I realize now that it's past 1 o'clock, but can we just do this last question? This looks very funny. What are we going to do here?
So there's a compound angle.
Where?
I like sine 4x cos 2x, then I can move the 2 to the back, and then I would have cos 4x and a sine x.
Oh, yes, well done. Okay, so can I just zoom in so that we can see it better? Let's go here. Okay, so this 2 that's in front of the cos 4x, if we link that 2 up with this sine x and cos x, then it forms the identity of sine 2x. Remember, sine 2x is equal to 2 sine x cos x. Okay, so this identity that we have here, that is going to be equal to the sine 2x. Okay, and that is a compound angle. Okay,
That's what I'm not saying. Okay. So,
yes.
that's not what I said, but that's another way of it.
Oh, what did you say?
I said just take the 2 next to the 2 cos x, and then I would have these like the bigger compounds, like sine 4x cos 2x, and then I would have cos 4x and a sine x.
I have no idea what you were saying, but okay, write it down, send me a picture. I'm gonna explain my way because I thought that was what you were saying. But you're talking about this 2 here. I don't know what you're doing with that 2. Anyways, this one, if you link
Minus
it up,
2, sir. I'm linking that 2 next to the cos x.
with what?
Well, the cos x right at the back. Like if I took the 2 next to the cos x.
No, wait. Are you linking this with that and saying that is cos 2x?
In front of it, sir. Not like at the back. Like 2 cos x.
But what is this equal? What would you do with that then?
Then I would like compound that one, and then I would times it with one another.
Okay, again, do it on your paper, then send me a picture. Okay, if I understand what you did, then I'll explain it. But like I said, I'm just gonna stick to my original idea of linking this to that, and then having the sine 2x identity. Okay, so let me just rewrite our numerator. We're still gonna have the sine 4x here, the cos 2x minus the cos 4x times, remember this now, the 2 and the sine x cos x, that is now going to become sine 2x. Okay. And all of this is being divided by the tan 2x. Okay, so the compound angle on top, this is the compound angle for sine. Sine A minus B. Okay, so the A is the 4x and the B is the 2x. So we can just say 4x minus 2x, which is equal to 2x. So basically you have sine 2x being divided by tan 2x. Okay. Actually, instead of dividing by the tan 2x, why don't we multiply by the inverse of tan? So if tan 2x is equal to sine over cos, we're going to say this is equal to cos over sine. So cos 2x divided by sine 2x. Because in doing this, that sine 2x cancels with this sine 2x, and you're left with cos 2x, which is equal to this right-hand side. The identity for cos 2x is cos squared minus sine squared. Whoa, hectic. Okay, please send me your picture, Muhammad. Then if I can understand that, then I'll explain it to the rest of the group. But okay, we're gonna end here. It's past our time.